Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on minerals. Well, in order to be classified a mineral, there's certain criteria that need to be met. Minerals need to be made in nature. They need to be made of something that was once non-living. That's what inorganic means. And needs to be solid. So oil and gasoline, those could not be considered minerals. Need to be made up of the same stuff throughout your sample. Your mineral needs to have some sort of chemical structure from the periodic table of elements and needs to have some sort of crystalline structure as well. Well, minerals are important because without minerals you don't have rocks. So we consider minerals the building blocks of rocks. Rocks tend to have different shades and different colors throughout. All those different shades and colors represent individual minerals that make up an individual rock. They're the building blocks of rocks. So the chemical composition is important because some minerals are going to be made up of a single element. Some are made up of a multitude of elements called a compound. The majority of your minerals on your reference table are going to be made up of compounds, such as NaCl and Fe2O3. So each mineral is special in its own way. Each mineral is going to have its own individual characteristics. Quartz is going to have its own individual characteristics. Pyrite, graphite, fluorite, they're all going to have their own individual characteristics. Very simply because of the way that the atoms have bonded themselves together. We call that the internal arrangement of atoms. So the way that the atoms bond themselves and arrange themselves within a mineral is unique to its own individual mineral. So each mineral has its own special properties, and we call that the internal arrangement of atoms. So you see the feldspar is dramatically different from pyrite. And probably the best example that we can give you here is graphite, which is made up of carbon, and diamond, which is made up of carbon. You have two completely different minerals made of the same element, carbon. It's just that the carbon atoms in graphite are arranged very differently from the carbon atoms in a diamond. So there are certain properties that help us identify minerals. So let's get to it. So the first one's color. Color is not a good identifying property because of the fact it changes so much. From sample to sample, okay, your color is going to vary tremendously. So you see that this sample of quartz, that's what we call milky quartz. This is a sample of rose quartz, still quartz, different color. And this is a sample of purple quartz, still quartz. Again, you notice you have three different samples, three different colors. So color is not a good identifying property, even though it's the first thing that you notice with a mineral. The exception to the rule here is going to be olivine, which is always olive green, and sulfur, okay, which is always going to be a nice yellow color. Those are going to be two minerals that you could use color to help identify. Luster is just the way that the light is reflected off the surface of a mineral. So you have either metallic. If it looks like a piece of metal, it's going to be metallic, or you can have non-metallic. It doesn't look like a piece of metal. Let's give you a couple examples here. So here's your mineral galena that has a metallic luster, looks like a piece of metal. Again, here you have a non-metallic mineral. Here's some feldspar that does not look like a piece of metal. So very important to identify the difference between the two. So just be careful though, because many times students will describe a metallic luster as being shiny. You can have shiny minerals that are not metallic. So this piece of quartz, for instance, is very, very shiny, but it is non-metallic. It's very important to know the difference between the two. Next up is streak. This is going to be the powdered form of the mineral. Very, very reliable property here. You're basically going to take your mineral, you're going to rub it across a porcelain plate, and what's going to happen here is that you're going to get the powdered form. Now you could have 100 samples of quartz with 100 different colors. Each sample of quartz is going to give you the exact same color. So very, very reliable property from sample to sample. That leads us to the way a mineral is going to break. Okay? You have two different ways. If a mineral breaks along a flat surface, it's what we call cleavage. If it breaks along an uneven surface, it's called fracture. So let's show you a couple pictures. So cleavage, okay, you see this piece of calcite, okay, has a really, really nice flat surface on a multitude of sides. If you have flat parallel sides to a mineral sample, it's most likely going to be cleavage. If you have an uneven surface throughout the entire mineral, you're dealing with fracture. So very important to know the difference between the two. Next up is hardness. Now this is based on Mohs hardness scale. Mohs hardness scale ranks minerals from a hardness of 1, which would be considered talc, to 10, which would be considered diamond. And usually with Mohs hardness scale, you will scratch a number of items against your mineral, and you'll take your mineral and scratch against a number of items to get a number between 1 and 10. Well, in earth science here, we're only going to focus on glass. If your mineral scratches glass, it means that the mineral sample is harder. If the mineral sample does not scratch glass, it means that that mineral sample is softer. Well, on Mohs hardness scale, glass has a hardness of 5.5. So within your reference table, if your mineral does not scratch glass, it's less than 5.5. If it does scratch glass, it means that mineral sample has a hardness of greater than 5.5. So here's just a quick example. There's your glass plate and your mineral sample, and again, you want to see if it's going to actually scratch the glass itself. Here's an example of Mohs hardness scale. And again, you can see the multitude, the range of values that represent Mohs hardness. There are some special properties that a mineral is going to go through. So if you take a look at some of these, some minerals are fluorescent, which means that they will glow underneath a black light. You can get some mineral samples that have magnetism, like this sample of magnetite. You can get some minerals that have double refraction, such as calcite. You can see that the mineral sample is going to be placed over top of that word. You see a double image of that word. It's what we call double refraction. And finally, calcite, which has a multitude of properties, also reacts with hydrochloric acid, so you get the bubbling when acid is put on. Now, a lot of these values and a lot of these properties are going to be found on page 16 in your Earth Science reference table. So make sure you know how to read that. Okay, that's it for now. Talk to you soon.